Welcome everyone. In part one's video, I had mentioned part two. I have modified what is going to be in this part two, so any of those references just kind of disregard, and we'll get to that in the following week. So what we're going to do is I felt like we really needed to focus more on how do we determine how many cues there are, how do we determine if it's a temperature phase or a phase change, and just kind of more of a conceptual model of that. So that's what this week's quiz is, or part two's quiz is going to be on. It's going to be like identifying, it's going to be zero calculations, and that's really what this set of notes is going to walk us through. So here we go. So we're going to call this week two, part two, and when we're going to be drawing maps and cues of a thing. So when we go through and we're doing these, again, we're talking about phase changes, and phase changes when we're changing states of matter and we're adding or removing heat. So I referenced drawing maps, and I didn't feel like I did a good enough job, so that's why I'm putting this part as part two, not a different part. So the idea is when we draw these maps, the first thing we should do is label our X and Y axis. So we're going to have temp on our Y-axis and Q or our heat on the X-axis. This is not temperature time. This is heat versus temp and heat. So when we're going through, it's going to be a problem, and it might be something, it's going to give you the substance. So like water starts at some temperature, 20 degrees Celsius, and it ends at final temperature, 50 degrees Celsius, 100 degrees Celsius, 200 degrees Celsius, right? So I'm giving you some temperature ranges, and then I'm going to ask you a series of questions. So how do we draw our map? So the first thing we want to do once we kind of read the problem, the key is identify the substance, because that's going to make a difference on whether we have a phase change or not. So then what we have to do is we have to go through and we have to add the maximum temperature to our Y-axis. So the idea is if this is on my Y-axis, this is my max temp. Now you would put a number there, like in the problem, water starts at 20, it ends at 50. This is where we would put 50 degrees Celsius, okay? So that's my maximum temperature. That's the biggest number it's going to get. So then we can go through and we can add the minimum, our minimum temperature, and we're also going to put that on the Y-axis. So now down here, this would be our minimum temperature. So again, in the example of water, it starts at 20, ends at 50. This would be 20 degrees Celsius. And then what we have to ask ourselves is, does a phase change occur between these temperatures? Okay, and if so, we're going to draw a dotted line. Now you could say, well, how do I know if a phase change is going to occur? Well, we look at a table. So this table has melting points and boiling points. So does the temperature range that I give you for that substance fall, is a phase change temperature, melting point or boiling point fit in that range? So for an example of water is between, I start at 20 and end at 50. Does 20 to 50 have a phase change? Does it melt? Well, no, because it's bigger than 0. Does it boil? No, because it's less than 100. So that's the idea of that. So you got to identify the substance, and then once the substance, you figure, does a phase change occur in that range? So if it does, then what we would put is we would put the temp of phase change right there, and then we are going to put a dotted line across because we get a plateau. Okay, so now what we're going to do is we're going to add a dot wherever the initial temperature is. Now we could start at the minimum. It could be, my initial could be here, or it could be here. It really depends upon the problem. Does it start at 20 degrees? If so, it's there. Or does it start at 50 degrees and go to 20? If it started at 50, it would be here. So you guys got to decide which one is it. Is it the minimum temp or the maximum temp? So we'll just say down here is going to be my initial temp. And then what we're also going to do is we're going to add a dot to the final temp. And my final temp is going to be up here. So then what we're going to do is we're going to draw a line that goes through from my initial temperature all the way up to my final temperature, But the key is I'm going to draw plateaus if there's a phase change. Okay, and then we also need to include the arrows afterwards to say, are we going this way or are we going this way? And then I'll show you that in a second. So in the example I have here, I start with my initial temperature down here, and my temperature is going to, as I add heat, as I add Q, my temperature is going to increase. But then what happens is when I hit that phase change, we get a plateau, and all of that energy that is being added or removed goes into that phase change until it's all gone through the phase change, it's all melted, all frozen, it's all boiled, whatever, and then we get another increase there. So that's my line with a plateau. And this right here is the plateau because this is the location of my phase change. Then what we need to do is we need to add arrows from, so we're going to add arrows going from the initial temperature to the final temp. So in this situation, we're going to go from here to here to here because it went from here up. So what this is telling me is that we are going to, my Q, my overall, the sum of all my Q's, like when we add all these up, is going to be positive. Okay, is going to be positive. And at each one of these situations, we have a different Q. So I'm going to call this Q1. I had a temperature change from here to here was a temperature change. That's a Q. So we're going to call that Q1. From here to here, that's my phase change. That's also a Q. We're going to call that Q2. And then from this temperature change from here to here, anytime my line changes from an angled line to a plateau to an angled line, anytime we get a change, that's going to be a different Q. So then up here, we are going to have a third Q. So in this particular case, we'd say, well, there's 3 Qs. Okay, so this is just a reference chart. This helps us identify whether phase changes occur for particular substances along the way. This is just kind of a review, so there's some reference. We talk about latent heat diffusion and vaporization, and it's really whether we're going solid to liquid or liquid to solid or liquid to gas or gas to liquid. So that's kind of the idea of that positive Q versus negative Q. Are we adding energy or are we removing energy? So those are just some things that we'll be kind of referencing along the way. So this is very similar to how your homework is going to look, and this is very similar to how your quiz is going to be for this part. Zero calculations is just really drawing a map. Now, on the quiz, I can't actually grade your maps, so you're going to draw the map and then you're going to answer these questions step by step by step, and I'm going to have a separate video that kind of gives you some tips on taking the quiz that I really, really think you should watch beforehand. So we're going to go through and say water starts at 10 degrees Celsius and it ends at 90 degrees Celsius. So this is really all the information that's given or needed. And then there's just a series of questions, and I'm going to ask you to draw a map. Was there a phase change? Is it going to be latent heat diffusion or latent heat vaporization? How many Qs are there, and are we gaining or losing heat? That's really the process, and that's going to be almost identical to your homework as well as the quiz. So when we draw these, remember there's like the 7 steps, and I encourage you to go through and reference that sheet. So we're going to go through and we're going to put temp and we're going to put Q on my axis labels. Then what we're going to go through is we're going to say, hey, this is water. So that's an important thing to remember. We're talking about water, so we're going to look at water on my chart. So then we say, hey, what is the maximum or the minimum temperature that this thing gets to? And we see the lowest temperature we have is 10 degrees Celsius. And then we go through and say, what's the maximum? And the biggest this number gets to is 90 degrees Celsius. And then we can say, then the next step, does a phase change occur? So from between 10 degrees and 90 degrees, does the water melt or does water freeze? And the answer is no, there is no phase change. So therefore, we don't have to add a dotted line. This is strictly a temperature change. There's no phase change. So then what we're going to do is we are going to add a dot at the initial temperature. So it starts at 10. So we're going to add a dot down here. And we're going to add a dot at my final temperature. So it ends up at 90 over here. Now, if you want, you could put like an I and an F for initial and final if you want, but it's not really necessary. Then we're going to draw a line starting from my initial to my final. And if there was any phase change, we'd have to draw a plateau and then continue going. But I didn't draw a dashed line because there was no phase change. So simply our line looks something like this because there's no phase change. And then I need to include arrows. So my line looks something like that. Okay, so that's what my phase change is. This is exactly this is my map. Okay, this is my map. I drew my map. So did a phase change occur? And the answer to this question is no. There was no phase change occurred. So if so, will a phase change, will it be LV or LF, latent heat of fusion or latent heat of vaporization? In this case, it's neither because no phase change occurred, right? It's not, that question doesn't really work. So then every time there's a temperature change, there's a Q. Every time there's a phase change, there's a Q. Every time there's temperature change, there's a Q. Okay, so if you have phase change, there's a Q. If there's a temperature change, so we say, well, how many temperature changes does the substance go through? And the answer is there's one. There's one Q. There is only one because this is strictly a temperature change. Now, was heat added or was it gained or lost? This is gained. Okay, it gained heat, and how do I know? Because it went from left to right. We went from a 10 to 90. We added heat to this system. Okay, so that's how we answer those questions. So we have a different one. So we're drawing a map. Again, we have water. Okay, so we have our map, temp Q. We're looking at water. We're looking at this column, or I'm sorry, this row. We want to add our minimum temperature. So we go minus 20. And that's my minimum, and it ends at 40. So we're going to put 40 up here. Okay, so there it is. So then we have to go through and say, does a phase change occur? Do those temperatures, do those phase change fall between those? Does a temperature change or a phase change occur between those temperatures? And in this case, the answer is yes. It's going to melt at that in between there. So because of that, now what we're going to do is we're going to put 0 degrees because that's the temperature at which my phase change occurs, and I'm going to add that dotted line. Okay, so we're going to add that dotted line. That's where my phase change is going to occur. Once we figure out where my phase changes occur, then we go through and say, well, where does this start? It's going to start at 20. Where does it end? It ends at 40, and I put my dots there. Now what we do is we connect that. So what happens is we add heat and my temperature of my ice increases. We call that Q1. Then we hit a plateau. We have a phase change. We're going to call that Q2. And then all that energy goes into that phase change, and then we go and we get another temperature change, and we call that Q3. Okay, so that's kind of my picture. Overall, I drew the arrows as we went. It was going from here to here, here to here, here to here. Hopefully you can say, hey, that's going to have then a positive heat. Okay, it's going to be gaining heat. So draw a map. Did a phase change occur? The answer to that is yes. That's why we drew that plateau. If so, was it latent heat of fusion? Are we going to be using latent heat of fusion or latent heat of vaporization? So melting goes with fusion. These two go together. These two go together. So this is going to be latent heat of fusion. Because every time I get an increase in temperature, that's a Q. Every time there's a phase change, that's a Q. And then I get another increase in temperature, we have another Q. So how many Qs are there? There's 3 Qs. And overall, because I went from bottom left to upper right, we can then also say that I can just circle it, we gained energy. Okay? Why don't you try this one? Water starts at 50 degrees Celsius and ends at 20. Hit pause, draw your map, circle the answers, and then unpause. All right, so your map, QT. Starts at my maximum temperature is 50. My minimum temperature is negative 20. Switch colors on you. Sorry about that. And we're still talking about water. So we're looking at this row and this row only. Okay, so between those temperatures, does a phase change occur? And the answer is yeah, it's going to melt or freeze. So at 0 degrees Celsius, we have a phase change that occurs for water. We're going to draw a dot where my initial temperature is. Now this time my initial temperature is in the upper right, and my lower is down there. Okay, so now I draw my dots, and now I draw a line from my initial. Sorry, I changed the light on you with my palm. So now what happens is I'm going to go to that plateau. I'm going to go from 50 to 0. My Q, that's going to be a Q1. And it's going down, so therefore I'm losing heat. Then I hit my plateau, so I'm going to have a Q, which we call that Q2. Now in this, we're going from liquid water to solid water or ice, so we're freezing. Okay, we're not melting now, we're actually freezing, right? This is really saying we are freezing because we are removing heat. But it is a phase change. Then we go from the freezing, and once it's all frozen, then we can go through and we can chill that ice further. So there's my map. Did a phase change occur? The answer was yes. Now, is it fusion or vaporization? Hopefully you can say it's fusion because it's right next to that freezing or melting point. How many Qs? We have 3 Qs because there are 2 temperature changes, 1 phase change, and in this case, we are losing heat. Okay, so now this is a similar one, but give this one a try. Hit pause, try this one. Okay, so hopefully you try that. This is water. It starts at 50, ends at 110. Q, oops, sorry, that's T. T versus Q. It's my maximum temperature is up here at 110. We're talking about water, so we're looking in that row and that row only, and its minimum is at 50. Is there a phase change that occurs between 110 degrees and 50 degrees? And the answer is yes. There is a boiling point, which is either going to be boiling or condensation, depending on which way we're going to go. And that occurs at 100 degrees. So we're going to draw a dashed line right there. Did a phase, so then we have our dotted line. We add our initial temperature as a dot, which is right there. We add a dot for my final, which is up there. And then we go through and we go up. That was a Q1. We have a plateau. That's my Q2. And then we go up to our final temp. That's our Q3. Okay, so there's my map. Did a phase change occur? Yes. Now, is this fusion or vaporization? And the idea is this has the phase change that goes along with boiling, so therefore it's going to be my latent heat of vaporization. How many Qs? There's 3 Qs. And then did we add heat or remove? And we're going from bottom left to upper right. Therefore, we are gaining heat. Last problem. I lied. Sorry, there's 2 more. Aluminum. So if we start now what I did is I switched substances on you. Okay, so we have aluminum. So temp Q. It starts at 15, ends at 200. So we go and we say, what's my maximum? My max is 200. What's my min? It's 15. Does a phase change occur for aluminum between these 2 points? And the answer is no. It has to be at 660 degrees in order to melt aluminum. We haven't reached that. 200 degrees Celsius, really hot, not enough to melt aluminum though. So there's no phase change, so therefore no dotted line. Then we go through, we add a dot for my initial, we add my dot for my final, and then we draw a line, and it simply goes like this. There is no phase change, therefore there is no plateau. So because there's only one line, there's only one Q. Did a phase change occur? No. So therefore, which one of these is there? It's neither. How many Qs? There's only one. Now, did we gain heat or did we lose heat? Well, we went from here. My arrow is going to the right. Therefore, we are gaining heat in this situation. Okay, so really the emphasis of this one is to say, hey, it's aluminum, not water, because if you ignored the fact that it was aluminum, you would have said, hey, that thing's going to boil and there's going to be a phase change. But it's not water, it is aluminum. So that's why I put this one here. This is the last one. So you try this one. Okay, you try this one on your own. Water starts at negative 15 degrees Celsius and it ends at 200. Draw that map, answer the questions, and then unpause me. So water starts at 15 degrees. It's water. Starts at negative 15. It goes up to 200. So I'm going to add my maximum temp, 200. I'm going to add my minimum temp, 15. Okay, so there's that. Does a phase change occur between there? This is negative 15. I forgot the negative. Between negative 15 and positive 200, does a phase change occur? Well, hey, we can say, oh, look at that. Water melts at 0 degrees, so that's between that. But also, we have boiling is going to occur. So we have to add 2 phase changes because we have a phase change that's going to occur at 100 degrees, and we have a phase change that's going to occur at 0 degrees. So what we have 2 phase changes that's going to happen. So we draw, in this case, we had to add 2 dotted lines. Now where does it start? It's starting here at negative 15. Where is it ending? It's ending up here at positive 200. So how many Qs are there going to be? Well, we have to determine that by drawing that line from my initial temperature to my final temperature. So we're going to start at negative 15 and we're going to add heat and we're going to go up and we're going to call that Q1. And it's going to plateau once we hit the freezing point or the melting point in this case. Okay, so then what happens is we get a plateau. We get a Q2. Then what happens after all that ice is melted, then that liquid water is going to heat up. Then what happens to my liquid water once it gets to 100 degrees? Then that is going to go through a phase change, which we call boiling, and is going to be a Q4, and all that water is going to turn into steam. And once that steam is removed, we can add more heat to the steam, and that's the key here. We're adding heat to the steam. And once we add heat to that steam, then we can go through and we can say, from that, we are going to get up to that 200 degrees Celsius. Okay, so was there a phase change? The answer was yes, and in fact, there were 2 of them. So if there was a phase change, is it latent heat of vaporization or fusion? Now this one is really both, right? There was both a latent heat of fusion and a latent heat of vaporization that we're going to have to use in order to determine the total heat gained or total heat lost. So how many Qs are there? There are a total of 5 Qs. And because this was going from bottom left to upper right, we gained heat again. So this is how we draw our maps. This is how we determine whether heat is gained or lost. This is very similar to the homework. If you get stuck on any of these questions during the homework, please jump into office hours and let me answer any questions that you have. Have a great day, everyone.